Okay, so in our last video, we talked about how to write more complicated redox half equations. Remember the three easy rules? Just remember as easy as 1, 2, 3. If I find that I've got oxygen in my redox half equation and it's not balanced, what do? I balance for oxygen with water. If you find you've got hydrogens, what are you going to do? Balance for hydrogens with H plus ions. Again, this makes sense because many oxidizing agents need acid in order for the reaction to work. If you remember, we used acidified potassium manganate to oxidize alkenes to diols, or acidified potassium dichromate to oxidize primary secondary alcohols. And this is quite important. Sometimes people get a little confused about this. Add electrons to the more positive side of your equation. So we're going to practice a few more of redox half equations using these rules in a moment. Okay, so we're going to build them up. So remember these rules, very, very important. So let's have a look at the first one, Fe2 plus ions becoming Fe3 plus ions. So do you see any oxygen? So do I need to use rule number 1? Do you see any hydrogens? Do I need rule number 2? So if you don't need them, you don't use rules number 1 and 2. You just add electrons to the more positive side and you should come up with your redox half equation. Remember why you're adding electrons to the more positive side? Because the two sides of your equation have to have the same overall charge. So 2 plus 3 plus, we're going to add 1 electron here. And now this redox half equation for Fe2 plus being oxidized to Fe3 plus is balanced. So Fe2 plus is oxidized because it lost electrons. So beneath is another redox half equation. This is hydrogen peroxide. It very often gets oxidized to oxygen. So let's have a look. What is not balanced here? So I've got 2 oxygens on this side, 2 oxygens on this side. So I'm okay. I don't need to use rule number 1. Oxygens are already balanced. But what I do notice is, I've got hydrogens here. So I jump straight to rule number 2. How do I balance for hydrogens? Add H plus ions. So I'm going to add H plus ions to this side. How many? 2 hydrogens plus 2 hydrogens there. So what else is going on now? I need to do rule number 3. You always use rule number 3 because these are redox half equations. Every half equation must have electrons on one side or the other. So let's have a look. Which is the more positive side? Well, on this side I've got a molecule, no charge. On this side I've got a charge of 2 plus. So this is the side where I'm going to be adding 2 electrons plus 2 electrons, so that now overall the charge on both sides is 0. Okay. Really, you need to practice these yourselves, and you will have opportunity to do this from our worksheets, which you'll find in the files section. So this is a more complicated one. This is actually the manganate ion, which is purple. We've seen it being used. And when it gets, it's an oxidizing agent, so when it gets reduced, it becomes pale pink or colorless. So let's see, let's use our rules. What do we have to do? So do I need rule number 1? Yes, I do, because I've got 4 oxygens here, no oxygens on this side. What's our rule? How do we balance for oxygens? Add water. now I've included some hydrogen. So what's our rule? How do I balance 4 hydrogens with H plus ions? How many H plus ions do you have? 4 twos are 8, so I need 8 H plus ions. Now take very great care. What is the charge on this side of your equation? 8 plus and 1 minus 7 plus. And on this side, 2 plus. So what's our rule number 3? Add electrons to the more positive side. So that's going to be this side. I need to add electrons until the charge on this side also becomes 2 plus. Can you work out how much that's going to be? I actually need 5 electrons. 7 negatives. 7 positives and 5 negatives give me 2 plus overall. Okay. MnO4 minus, make a note here, gains electrons. MnO4 minus is reduced. So MnO4 minus is a very good oxidizing agent. How can I tell it's a really good oxidizing agent? Because it actually gained quite a lot of electrons. The more electrons it gains, the better the oxidizing agent. Okay, remember this. It's reduced, it's the oxidizing agent. So let's see now. This cannot happen by itself. A redox half equation can never happen by itself. It has to happen together with one of these half equations. Okay.